We have another lecture video on stoichiometry, and this time this is going to be involving what we call limiting reactant problem. Now, why is this called a limiting reactant problem? So we're going to be talking about reactants, and if you recall from chemical equations, reactants are, in this case, the substances or the compounds on the left of the yield arrow, whether it's bidirectional or unidirectional. So what happens is if you mix two or more reactants, unless one of if they're not equal in terms of proportion, what you're gonna have is you're gonna have something, one of the reactant, that will limit the yield at the end. And a very quick example of this, which is used throughout the history, I guess, of teaching stoichiometry, is a sandwich, right? A sandwich always requires, let's say, a ham sandwich. And we're gonna just talk about a plain ham sandwich. So a ham sandwich is one piece of ham and two pieces of bread, right? Now, if you have a whole loaf of bread in your pantry, but you only have two pieces of ham in your refrigerator, the limiting reactant on how many ham sandwiches you can make is the ham. Since you only have two pieces of ham, regardless of how much you have of bread, the limiting reactant in that whole analogous in this equation is going to be the ham, right? So you can only make two ham sandwiches because you only have two pieces of ham, right? Now, on the other hand, if you have two pieces of ham but you only have two pieces of bread, and we're assuming that you're a regular person who makes a sandwich with two pieces of bread, well, the limiting reactant in that case would be the two pieces of bread. So this is actually the best analogy I have for you for limiting reactant problems. Now, bread, ham, cheese, all of those other household items probably looks great, and you probably followed that. But what happens when we actually apply that with chemical reactions? So here we have a balanced chemical reaction. Again, I promise you that I will always give you a balanced chemical reaction in the creation of water. Two hydrogen, right? Two diatomic hydrogens plus one oxygen molecule gives you two moles of water. So in this case, we're going to mix 10 grams of hydrogen and 10 grams of oxygen, and we're going to figure out which one of this is the limiting reactant, right? And if one of them is the limiting reactant, what that means is one of them is what we call the excess reactant. So that means to say there's going to be left over of that excess reactant at the end. So how do you proceed with this, in this case, limiting reactant problem? This is just a plain stoichiometry problem. So if you recall from the previous lecture videos, I showed you how to go from like figuring out which you're starting from and where you're ending at. So this is just a mass-to-mass problem, right? So, but obviously now we have two reactants and we only have one product. We're only talking about water. One of the things that we do is we first need to decide which one of this is the limiting reactant. So one of the things we can do is we can just set up both of this with mass, and all we're doing with this two is we're going from mass to moles, and we're going to the moles of the product, water. There's a caveat to this one. If you have three reactants and three products, God forbid, what happens is you can pick any of the products to figure out which one is the limiting reactant. Okay? So it's just a mass to mole problem for both of them. And we're going to the moles of the common product at this point. So if we set this up, we go from, it's a gram to mole, so which means we're going to be using the balance equation once for each one of them. 10 grams, convert that into moles. Again, using this ratio, 1 mole and like underneath is the molar mass. 10 grams of oxygen. Again, the molar ratio, in this case, the mole to molar mass ratio for oxygen. And then note here the difference between what we're using in the balanced chemical reaction. The ending is the same. We're ending with moles of water, but the bottom numbers are different because in this case we're starting with hydrogen. So in hydrogen's case, we have 2 moles of hydrogen. In terms of oxygen's case, we only have 1 mole of oxygen. And so what happens is if we go from grams to moles for both of them, and again, we're trying to go to moles of water, one of them will give you the smaller moles of water. And the question is which one of them have a smaller mass of water, and so we can see it's this number. 0.625 moles is definitely way smaller than 4.97 moles of water. So the limiting reactant in this case, folks, I shouldn't say folks because that drives bananas, is oxygen. So the limiting reactant is oxygen, which means to say that the excess reactant is the hydrogen. Okay? So the question says how many grams of water. So now we're going to have to keep going. So we're going to use this small moles of water, the smaller moles of water, twice actually. So once to figure out the moles of water, and the second time to figure out how much hydrogen is actually left behind. So for the first step, we use the smaller moles of water, and now we're going to keep going to find out how many grams of water is actually created. So in this case, we're here basically, and we're just going to move on to the mass. If you can see, this is actually what this is being shown here. Again, if we go from moles to mass, it's the molar mass on top, 1 mole on the bottom, shown here. And the creation, how much water we created from the limiting reactant is actually 11.3 grams of water. So that is answered already. So this answered that. Question is, how much hydrogen is left behind? Again, we're going to be using the same. We're going to be using the smaller moles of water. And now instead of going from moles of water to grams of water, we're going to be going from moles of water to grams of hydrogen. So now we're going to be basically flipping this on its head. We're going to be going from moles of water to grams of hydrogen. So to the grams of the excess reactant. And again, 0.625 moles of water. We're going to cross the balance equation. Now the required substance, now the new substance is hydrogen. The given substance is water. And again, we keep going. And what happens is if you take the smaller number, okay, you should come up with a number that is way, or in this case, smaller than the excess reactant. So we only use 1.26 grams of hydrogen out of the 10 grams of hydrogen. This is why this is excess. We only need 1.26 grams. We have more than enough grams of hydrogen to start with. So how much of the excess reactant is left behind? It's a simple subtraction problem at the end. The initial minus what's used, and this is how much hydrogen is left over. This is probably a confusing lecture video. But the key first is you need the basic of this thing is knowing how to use this table. So in the initial step, we calculated the moles of the new substance of the product, two reactants going to the same product twice. And it's a mass to mole problem. We picked the smaller mole. The smaller mole tells us which one is the limiting reactant. The bigger moles tells us which one is the excess reactant. From that point on, we're going to be using the smaller moles of the product twice. The first one to figure out how much grams of the product is created. And the second, how much of the excess reactant we actually used. And the ending step for this typical limiting reactant problem is a subtraction. So obviously we have 10 grams of hydrogen, we only use 1.26 grams. There's going to be 8.7 grams of hydrogen left over. Note, everyone, that all of these numbers follow the rule of significant figures. 3 significant figures, 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 3 significant figures. There's a little wrinkle here. When we add or subtract, it's no longer about significant figures, it's about degrees of precision, 10th place, 100th place. The least precise is the 10th place. That is why our answer has to be in the 10th place. Okay, again, we're gonna go through a bunch of problems, and we're gonna go through, and hopefully you will work through some of your textbook problems as well. Please make sure that you review this video not just once, but hopefully at least 5 times.